Good morning, students. Today we will see functions and function we have studied in last class. Relations and types of relations we have studied, and today we are going to start with functions. Okay, now functions. So function as a set of ordered pair. It can be represented as a set of ordered pairs. Let A and B be two non-empty sets. Non-empty sets. A relation F from A to B, that is a subset of A cross B, is called a function from A to B if number one, for each A belongs to A, there exists B belongs to B such that A B belongs to F. And the second point is A B belongs to F and A C belongs to F. That implies B equal to C. In other words, a function F from a set A to a set B associate each element of set A to a unique element of set B. If a function from a set A to a set B, set A and set B, from set A to set B, then we write as F, then colon, A and arrow and B. This is a format to write. and, or this is also one of the format, A arrow B, and above the arrow write F. F is function. This is two format we have to write or express the function, and read as it is read as F is a function from A to B. F is a function from A to B. Or better we can understand, let us say this is set A and this is set B. So there is some elements likewise, and there is some elements, so I can say this is from set A. There is another set another element in set B, which is the function shows this is F. It is like it. So whatever we are getting in set A and set B, we will define this also. And set A is known as the pre-image of B. So whatever the elements you can see over here, that is known as pre-image of this particular B. Say this is the point, so image of pre-image of this point is this one, as we can see here. And also here this is known as functional image of A. This is functional image of A, or it can also be said as image of A under F. So these things are terms we need to understand before going further. And also this entire set A is known as domain. Entire set B is known as codomain. Then one can ask, what is range? So for each and every element of A, whatever we are getting, the exact value are known as, say, this one, right? So this is nothing but range. We'll see some more functions, and these functions are, first one we'll consider modulus function. Modulus function. The function is defined as f of x is equal to modulus of x, or also it can be written as x and minus x, and we will get x when when x is greater than or equal to 0, and we will get minus x when x is less than 0. So these two values we will get, and this function is called modulus function. It is called as also called as absolute valued function, absolute valued function and modulus function. If we draw a graph of this function, we will get likewise. This is y equal to modulus of x. Whatever we are getting is x, x dash, y, y dash. So this is the graph we are getting. One can put any value of x, whether that is positive or negative. Y will be positive only. So here we can see, if I put x equal to say positive value, then definitely we can see here that y is positive, and where I put this negative value of x also, I am getting the positive value of y. So this is nothing but modulus function. One of the most important function, later on in the integration also we will come across these functions, so we should understand very well. Greatest integer function. Greatest integer function, it is also known as floor function, floor function or step function. There are so many names of this particular function. So we'll see that for any real number x, we use as a symbol x, and that is into that is inside the square bracket, or we use this symbol this one to denote the greatest integer less than or equal to x. This is very important thing, this one. Greatest integer function is said to be or symbolically it is defined by this symbol, and also it is less than or equal to the x, or we can see the example first. Let us see the example. If it is written that 2.75, then we are going to write 2. If we say 3, then this is equal to 3. If we write 0.75, then it will be equal to 0. And if we write minus 7.45, then it will be equal to minus 8. Likewise, we can solve some more example also. Then the function f from R to R, function f from R to R is nothing but both are real numbers, is defined by f of x equal to, this is x in square bracket, it is x, for all x belongs to real number. So this is, we have seen. We'll see the graph also. Say this is x, this is x bar, this is y, this is y bar, and let us start from here. This is 0, we'll solve here for 1. Definitely this is 1, this is 2, then this is 2, and this is 3, and so on. Here also we can draw likewise. So greatest integer means if you are getting a value, for example, this is 1, this is 2, this is 3, this is -1, this is -2, and so on, right? So it is 1. So if you have 2 point anything, we have written 2.75, so it will come somewhere here. If that is the case, then definitely we have to mark 2 over here, and 3 is not considered. That's why it is open and this is closed. This is open symbol and this is closed symbol. Over here, if anything less than 2, then we have to consider as equal to 1, and 2 it is open, at 1 it is closed. So this is greatest integer function. Then we'll consider the next one, that is the smallest integer function, or it is also known as ceiling function, also known as step function. And the symbol for any real number x, real number x, we put a symbol, this is x, like this. Likewise, is smallest integer greater than or equal to x. So this is important term, you should understand this one, greater than or equal to x. So we can see the example. Some examples are 4.7, 4.7, so it can be written as equal to 5. If we write 0.75, it will be equal to 1. If we write -7.2, it will be equal to 7, -7, and likewise, so you can understand these are the examples. Then the function f, a function f from R to R is defined by f of x equal to x with this symbol, for all x belongs to a real number. And we'll see the graph of this one. So this is x, this is x bar, y, y bar. It is open at this point and close it at this point, opposite of the previous one. Open, close, open, close. Likewise in this field also you can generate it. This is open, this is open, and likewise we can solve it. Now coming to the next function, that is for fractional part function. Next function is fractional part function, and in this, for each and every real number x, we write or we put a symbol, that is you have to write that number in between the curly brackets or inside the curly bracket and is denoted fractional part or decimal part of x. So this is the important one, fractional part or decimal part of x. One should understand these things. So what is it? For example, let us consider 4.7, then this is 0.7. If we consider 75 minus 2.75, then it will be 0.25, 0.55 with minus sign equal to 0.45, or if we write 3, then we'll get 0, or if we